Coding interviews are probably the dumbest thing on the earth. As a computer scientist, you probably know about coding interviews. They're basically just puzzles that you have to solve based on past experience or classes. And in my opinion, they are not a great way of seeing if a person's a good candidate for a job. But what do I know? I'm not a hiring manager. Regardless, one of the most common coding interview questions is how to reverse a linked list. I personally have not been tested for this in a coding interview, but a lot of my friends say that this is one of the most common questions that they get asked in coding interviews. So today I'm going to show you how to reverse a linked list because it's really easy. After watching this video, I hope that you get tested for this interview question and you just ace it. Let's get right into it. So we're in a .cpp file and this is going to be in C++. So I'm going to start by just declaring a linked list, showing you how to implement it. The only member functions that we are going to do for this linked list are adding and printing. I'm not going to get into any removal or sorting, and if you want a thorough explanation on that, I can make a future video on that. But to start, the only library that we actually need is iostream. This is just for the print statements. One more note that I want to add before we really get into this is I'm going to do it all in the .cpp file, but a good programming convention is to put the class declaration in a .h file and then include it in your cpp file. We'll then do using namespace std, just so we don't have to do std before all of our standard library calls. Next, we'll do class linked list. At the end of all your class declarations, which is different than a function, you want to do a semicolon like that. So within a class declaration, you have your public and you have your private members. Public means that the class variables can be shared across functions, can be called really wherever, whereas private means that those variables and those functions are called only within the class itself. So I'm going to show you what that means. Usually with the class, you want to start off by just doing private and public like this. I spelled private wrong. Embarrassing. In public, we are going to declare another class, and this is going to be our node class. So once again, we're going to add a semicolon at the end of our curly braces. So within our node class, we are also going to have public variables, and our first public variable is going to be the value of the node. Linked lists are just little blocks of data, and you can do this with any type of data. It does not have to be an integer as the data that the node contains. You can even do another class as the data type. But to keep things simple and just for reversing a linked list, we're just going to do integers. The main purpose of doing a linked list is to learn about pointers. So this one's a little weird. We're going to do node pointer, and this asterisk symbol right here means that this is going to be a pointer. So this is a pointer to a node. We're going to put next, and then we're going to have a simple constructor. To declare a default constructor for a class type, you just do the name, parentheses like this, and curly braces. Inside the parentheses, I'm gonna put an integer new val, and in the curly braces we'll put this. This is to mitigate any confusion about what variable we are calling. We are making sure that we are calling this val right here. Val equals new val. So what this will do is if we create a node with a inputted new value, it's going to set our node value to this inputted value. Now let's get into our private variables for the linked list. So in private, we're going to have a node pointer once again. This is going to point to our head, or the start of the list. We are also going to have a node pointer tail, which is going to point to the end of the list. I actually just realized that I didn't do this right. We're going to put node as a standalone class within our linked list, but we are going to have some public members. We're going to get into that right now. In public for linked lists though, we are going to have our default constructor, our default destructor, a void function that's going to add an element, and we're going to give it a parameter of a integer, a void function that's going to print our linked list, and a void function that is going to reverse our linked list. So now that we have everything declared in our class, let's start implementing each of these functions. We're going to do linked list : linked list, and this is going to be our default constructor. This notation is how you declare any member functions of a class. You put the name of the class, this is the same as this guy, and then you do the actual function name. If you notice with these functions, we have a data type, which is void, which means no return. So to do that, we would do void linked list : linked. Well, actually this function is called add element, and then we'll do int val. Going back to our default constructor, it's going to be this head equals null pointer, and this tail equals null pointer. This is going to declare an empty linked list. Before we start adding elements, let's create a default destructor. Default destructors are great because they make sure that your memory that you've allocated is deallocated after the process is run. Other programming languages such as Python deallocate your memory usage after the memory goes out of scope or is just not used anymore. But in C++, if you declare anything with the new keyword, you have to delete it. So within our default destructor, we will do while our head does not equal null pointer, node pointer equals head, head equals head next, delete pointer. What this will do is iterate through the linked list using the head, and it's going to basically increment the head through the linked list and delete items behind it as it goes. In add element, we need to do a few test cases. It's always good to be mindful of your edge cases or test cases, which are basically like the different conditions that you have when you are manipulating the data. For example, if we're adding to an empty list, it's going to be different code than if we're adding to a list that already has elements. In add element, we first need to declare a new element that we are going to add, and I'm going to shorten this to elim, and we're going to put the new keyword node, and since our default constructor already has int new val as the argument, we can just put the value that is passed to our add element function, val. So like I said, our two test cases is if the linked list is empty and if the linked list is full. So we'll do an if statement here and we'll do an else statement. In our if statement, we're going to put if our head equals null pointer, which means that we have an empty list. We are going to set our head to our element and our tail to our element. And if the linked list is not empty, we are simply going to append it to the end of the linked list, which would be tail next equals our element, and our new tail is going to be our element. For example, if we have 5 as our linked list, that's it. Head and tail are both going to be pointing to 5, but if we add 4, 5 is the tail, so 5's next is going to equal 4, and our new tail is going to be 4. Head does not change because it is going to always be the first element of the linked list. Next, let's get into our print function. Void linked list print. Similar to our default destructor, we are just going to iterate through the list. So we can just do node pointer equals head, and then while pointer doesn't equal null pointer, see out pointer arrow value and line. Since our pointer variable is pointing to a node object, we use this arrow to point to the value that the node object contains. And then after we print this value, we need to iterate to the next element, pointer equals pointer next. So with these functions, we have declared a very simple linked list. Let's make sure it runs before we get into reversal. So to declare a linked list in our main function, we'll just do linked list as our data type, and we'll just call it my list. Let's do a for loop to add elements. We'll do my list dot add element, and we'll just add the iteration number. I'm gonna make this a little cleaner and have it start at 1 and go to 16, so that the linked list is the numbers 1 through 15. So then we will do my list dot print to print out our list. And as you can see here, we have a linked list of 1 through 15. So now let's get into reversal, which is why you're here. All you need to do is declare 3 temporary pointers and then just move the pointers. And this is with a single linked list. A double linked list is just adding a few more pointer changes. I believe it's 6. It might be 5. For a single linked list, it's really simple. All we got to do is do 3 pointer changes. We're going to declare node pointer current, which is going to equal our head, node pointer next, which is going to equal null pointer for now, and node pointer previous, which is also going to equal null pointer for now. Then we're going to have a while loop to iterate through the linked list and change all of the pointers. We're going to say while our current pointer does not equal null pointer, our next pointer is going to equal our current next. Our current next is going to equal our previous pointer, and our previous pointer is going to equal current. This is for the next iteration, and current equals next. Let's go through this to make sure that you guys understand how this works. So first, next starts off as null pointer. We're going to assign it to our current pointers next. Let me just put this down here. If we have 1, 2, 3, 4, 5. Imagine this is our linked list. We first start off with our current being our 1. We're going to set our next to our 2. Our current next, which means the next pointer, of our current node is going to equal previous. Our previous pointer is pointing to null PTR. This statement right here points 1 to null PTR, which is exactly what we want. We want this 1 to point behind it, or to nothing. Then our previous is going to equal our current node, so now it equals 1. And our current equals next, so now current equals 2. So we're going to go through the iteration again. Our next pointer equals 3 now. Our current next, which is our 2's next pointer, is going to equal previous, which we had set to 1. And then our current equals next, which is 3. So it's going to do this over and over again until it gets to the end. When current equals next and our next is null pointer, then we are done. This statement I'm going to write is optional, and it is only if you are using the tail member variable. Some linked lists only have a head, but if you have a tail as well, you should also do if current next equals null pointer. We're going to set our new tail to current. Basically means that after we reverse the first node pointing to null PTR, which means behind it, we are going to set this 1 to our tail. And the next iteration, when it goes to 2, it's not going to set it to tail because 2's new next pointer is pointing to 1. And then finally, after reversing our entire linked list, our previous pointer is pointing to 5. So we're going to set our new head to previous. So now let's see if it actually works. If I do my list dot reverse list and then my list dot print, let's build and run this program. So this is our first linked list 1 through 15, and then after the dashed line is our reversed linked list, which looks like it did it perfectly. So this is how you reverse a linked list. It's really not that hard. I've had programming interviews that have been more difficult than this. I'm gonna get into that in a future video because I totally messed up on a coding interview, and I think it's a great experience to share. But this is how to reverse a linked list. So if you ever get asked this, I hope you feel confident now to be able to do this. It's really not that difficult. Anyways, that's all I have for today. Thank you so much for all the support lately. It's really motivating. We hit 1,300 subscribers, which is just a crazy breakthrough. I'm very grateful for you guys. Thank you so much, and I will see you guys in the next video. Peace out.